I want to spend a few minutes today talking about analyzing network data, which is something that's a big part of what we do at Preseam. These slides are from a talk I did at WISPAPalooza 2024. I thought this would be useful, so I'm re-recording it and we'll be uploading it to our Preseam YouTube channel. This presentation is called Collecting Network Data for Fun and Profit. No, it's not for fun. I hope we can have some fun talking about how we collect and analyze network data, but this is not something we do for fun. This is really about how we can use network data to deliver real business value. I'm going to talk about 4 different techniques for analyzing network data. I'm going to go through each one of these and use some real network data to demonstrate it, and you're going to see how these techniques build on each other to get to that end goal of tying network data directly to business results. Let's start with trending. Trending basically means looking at data over a period of time to identify patterns in the data. So let's look at a simple example. I want to use some simple bit rate over time data from my fiber network to see where I should look at adding capacity next. So where should I place my bets, on PON 1 or PON 2? These are 2 PON ports on an OLT. I'm looking at data over the past 2 days here. Does this data help me understand which one to look at? I see some spikes in the bit rate. It's kind of random looking though overall. Doesn't really tell me much. And besides that, it's only 2 days of data. So can I really draw conclusions from that about decisions for my network? So let's zoom out a little bit and look at a month of data. So you can start to see some patterns here. You can see some peaks and troughs due to peak times of the day. There's some spikes in usage that may indicate some sort of network event. But I still can't really answer my question. These both have pretty flat growth from the looks of it. So let's zoom out more. So we're looking at 9 months of data now, and now this gets more interesting. With this level of data, you can see a pattern emerge. Looks like PON 1 is growing, and it looks like PON 2 is relatively flat compared to PON 1. So if I'm looking at where I should upgrade my network, I'm going to put my money on PON 1. So trending lets us see patterns that can help us take a more proactive approach to network operations and lets us make better decisions as we look at data with a longer and longer time horizon. If you're storing network data, or if you're evaluating vendor tools, make sure you can store a year or 2 of history and that you can easily see those long-term trends, that you can quickly bring up those long-term charts, because the longer your time horizon you're looking at, the more valuable the data is for decision making compared to looking at very recent data. You get much more signal out of the noise if you're looking at the longer term trend. The second principle I want to talk about is adding context. Adding context means joining data from different data sources together, and then by grouping the data, you can reveal deeper insights about your network. Let's look at an example. This is a graph from a QoE system at a tower site in a network. So that system measures latency between a QoE appliance and the end user devices for all subscribers served by that tower. So do we see any useful insights from this data? I would say not really. It's kind of flat with some variation around 40 milliseconds. That doesn't really tell me much. So what we're going to do is we're going to add some context. For each latency sample in this data set, we're going to add the access point that sample transited, and then we're going to group by the access point. So here's the result, and the result uncovers something interesting. While most of the access points are clustered down around 40 seconds, like that sample we started with, we have one access point that's much worse, way up here above 100 milliseconds. So that might be a problem. It's certainly something interesting. We're going to continue with this example, but first I want to say something about adding context because we're going to move on to our next technique. A couple of points when you want to add context. Number 1, it's interesting to be creative about what context we should add. It should be ultimately something that's useful, so what in this case might contribute to a high latency, well, maybe the access point, because those are points where packets buffer, where a latency can be added. And number two, it should be something we can control. So if the access point turns out to be a problem, there's something we can go and do about that. It's actionable. The second point here is when we're adding context, we should consider where that context is coming from. So what is the source of truth for that context we're adding? Is that source of truth going to give us data that's accurate and complete? And I could do a whole nother talk on that, so I'm going to move on. So benchmarking. We talked about trending, which helps us understand patterns. We talked about adding context, which helps us make the data more meaningful by adding context and grouping it. But how do we know if what we're seeing is good, bad, or somewhere in between? And that's where benchmarking comes in. Benchmarking is really just comparing your data against similar situations or against standard data. So let's go back to our high latency access point. It had a higher latency than other APs on the tower. I'd like to understand whether this is actually a problem, and if so, what should we do about it? Where should we look for the source of that problem? So I'm going to look at this access point. This is the high latency access point. And this is just the web interface. This is an ePMP from Cambium. This is the web interface for that access point. And normally what I'm going to look at if I'm evaluating the performance of radios connected to my access point is a downlink modulation. So if I look at that, I've got kind of a mix here. I've got some MCS 5s and 6s, 9s and 7s. I've got this downlink capacity score that's maybe a concern, I'm not sure. Just by looking at this, though, I can't tell if this is the cause of the problem, or even if really this is bad. So I'm going to compare it, I'm going to benchmark it against another access point on that tower, one of the ones that had one of the 40-second latencies. So here it is, here's another access point. So does this look better? So I've got some 6s and 5s and 9s. I've got another downlink capacity that's colored orange here. It's hard for me to tell just by looking at this whether this is indicating a problem or not. They're not seemingly that different. So instead of using my eyes to pick out patterns from this, why don't we use a technique we've already learned about, which is trending, to help us find whether there are any interesting patterns here. So this chart looks like a bit of a dog's breakfast, but this is the trend of all the different radios MCS levels over time for that high latency access point. And it looks like we've got kind of various patterns here starting at MCS 4 and going up to MCS 10. So let's look at one of the lower latency access points. Okay, so now we're getting somewhere. This trend looks much different, right? It's a much tighter cluster, kind of grouped between MCS 7 and MCS 10. So it has higher MCM rates, and so what I might conclude from this is that there's definitely a difference here based on the MCS rates. It looks like the MCS rates for the high latency access point are potentially causing that problem. And so I might look for a root cause of that, such as an interference issue, since that could create a problem that affects multiple radios and could cause that high latency, and do some experiments with that, which is nice because I don't even have to roll a truck to do some of those reconfigurations on the radio. So I'm going to take this one step further for benchmarking, and I'm going to compare it to an industry benchmark, because that's really going to let us determine whether this is a problem or not. So now I know why there might be a problem with access point 1, but does it matter? Is this actually bad, or is it just worse than the other access points on the tower, but not actually that bad overall? So here is a chart that shows the industry benchmark. So we're comparing that particular access point, which is an ePMP in 3000 with 40 megahertz channel width, to all of the similarly configured same model access points that Perceive, in this case, monitors. And what we're seeing is that a typical access point would have a latency just under 50 milliseconds, and that ours has a latency clear up here over 100 milliseconds. So we can see that this is indeed bad and there's much room for improvement, and that if we solve the problem, we should expect that we can get the latency down here to around 50 milliseconds, which will proactively create a much better subscriber quality of experience. And just for completeness, here's how our reference access point looks according to its industry benchmark. You can see that that's much closer to what we would expect. So that's benchmarking. This can be a powerful tool for making your network data useful in a proactive way, and you can use this to understand whether some metrics actually indicate a problem so that you can prioritize what preventative troubleshooting you should focus on to improve your network. The last technique I'm going to talk about is scoring. Scoring means taking a set of entities, such as customers or network devices or sites, and adding context to these entities, and then assigning a value or a rank to each of these rows to evaluate some performance or some potential action. And this is where we're going to tie network data directly to what matters most to an ISP, or really to any company, which is profit. So here's an example. This is an upsell report, and here's how we're using network data to make better decisions on how we can upsell. So for each customer, I'm just going to create a big list of customers for my entire network. We're going to take their current plan into account. Then we're going to take a usage value from the network. So this might be, for example, it's high if they hit their download rate 5 times for a sustained period of 30 seconds over the past month. So some heuristic will come up with like that. We'll take the RF data of their CPE radio. So do they generally have a good modulation? We don't want to target customers with a poor modulation because they may not be able to hit the higher plan speeds, or if they do, they'll take more than their fair share of airtime on the access point. And is the access point using most of its airtime? So we really just want to upgrade customers on access points that have a lot of capacity remaining so that we don't have to do any CapEx upgrades, put up any new access points as part of this. So our logic here, once we've got this populated with the plan data from our billing system and these other attributes from our network, is we're going to go through each customer and we're going to come up with some score, which the result is upsell no or upsell yes, based on some thresholds that we'll set for this data. So for example, this first customer, he's not hitting his plan speed, he's got a fairly poor modulation, and the access point's relatively full, so this is a clear no, we don't want to try to upgrade him. Customer 2001, as a second example, he is hitting his 50 megabit plan rate. He's got a great modulation, so he could use much more without having a big effect on the access point, and the access point's only half used anyways, so he goes to a yes. And now what we're going to do is we're going to add some dollar signs to this. We're going to take all of the yeses and we're going to subtract the cost of the plan they're on from the cost of the plan we want to upgrade them to, sum those and maybe group them by our region if we think about our network that way. And then we've got an upsell potential dollar sign. So we've now linked our network data here directly to dollars profit for our company, and we can tie this into maybe a quarterly objective that we might have next quarter. So maybe our objective is get more revenue from existing customers, and our key result that we're going to measure from that is we're going to have a sales campaign that upgrades 50% of this upsell list. So our expected return on that would be an additional $210,000 in monthly revenue for our business. So with scoring, we can use data from the network to drive real business results, building on what we learned about trending, adding context, and benchmarking. And this is one of many ways we can use network data to link directly to business revenue and profit. So if you made it to the end of this talk, I want to thank you for listening. I hope it gave you something to think about. For additional resources, check out our Fixed Wireless Network report, where we use many of these data analysis techniques to provide some interesting benchmarks and insights into the fixed wireless network ISP industry. You can also check out a recent case study we did with Airbridge Broadband, where they talk about how they've used the insights from Perceive to help improve their business.